All right, so we're looking at this question here. 2x over 4 plus 3x over 6 plus 5x over 8. When we work in a question like this, we approach it just like we would a fraction. So pretend if you was doing 2 over 4 plus 3 over 6 plus 5 over x. How would you do something like that? Well, you have to find your LCM to begin with first. So you have 4, 6, and 8. Right? The LCM of 4, 6, and 8 would be 24. We will say 4 into 4 is 6, and 6 by 2x. Then we would say 6 into 4, 24 is 4, and 4 by 3x. Then we'll do 8 into 24 is 3, and 3 by 5x. We then multiply, and we'll get 12x plus 12x plus 15x. Twelve and 12 is 24x. Always add from the left going across to the right, and put them in pairs. And then 24x and 15x going to give them a 39x over 24. Easy peasy. Yeah? All right, let's look at this one. We're going to have the same approach here. The difference is that we have both numbers and letters in the denominator. So we could look for the highest common factor between the numbers. So 3, 4, and 6. The highest common factor, the lowest common multiple there, is going to be 12. And then we're going to look at the letters. In this case, the common multiple is going to be x. And then we will follow the same process. 3x into 12x. If we're not certain, we could go in our working column and we could work that out. So the x's will cancel. 3 into 12 will give me 4. And we'll do 4 multiplied by 5. Plus, again, 12x divided by 4x. The x's will cancel. 4 will go into 12 3 times. So I get 3 by 6 minus 12x divided by 6x. The x's will cancel. 6 will go into 12 2 times. And we get 2 by 2. We work that out. We're going to get 20 plus 18 minus 4 all over 12x. Remember, add from the left going across the right. So 20 and 18 going to give us 38 minus 4 over 12x. That's going to give us 34 over 12x. And that's how we work this one out, right? So notice the difference. In this one, we had all numbers in the numerator. So our numerator is all numbers. The denominator is our algebraic term. It was the opposite way around here because all the numerators here were algebraic terms and all denominators here were numbers. Yeah? Let's look at another example. Right, so we have 7 over 9pq plus 5 over 18p, right? Now, what we want to do, just like the others, we want to find our lowest common denominator, lowest common multiple. So I tend to look at this with the numbers first, then the letters. So lowest common multiple of 9 and 18 is going to be 18. What we're looking for is a number that both 9 and 18 could go into. And then when we think about the expression, we need an expression here or a variable part that both PQ and P could go in. Usually it would include all letters in the denominator. So if I have a PQ and a P here, I need to have both PQ in my lowest common denominator at the bottom. So 9 PQ into 18 PQ, if you're not certain about it, I would recommend that you just go quickly in your working column and you divide 18 PQ by 9 PQ. We'll cancel here, we'll get 2 and the PQs will cancel out. So what we will get is 2 multiplied by the 7 here. Bring down this plus sign. And then we have 18p divided by 18pq. The 18 will cancel, the p will cancel, and we'll get q multiplied by 5. So that will give us 14 plus 5q over 18pq. Yeah, that makes sense? All right, so let's look at another example. Here we have 5x over 3y minus 4y over 9x. So this one, slightly similar, but a little different in the sense that the letters we have in our denominator is different, right? In a case like this, we're doing the same thing. We want to find the lowest common multiple of 9 and 3, which is going to be 9, right? You're looking for the smallest possible number that both 3 and 9 could go into. And then in terms of the letters, you need to have both letters there. So the lowest common denominator is going to include both the x and the y, so that both y and x could go into that. So we'll get 3y into 9xy. Again, if you're not sure about it, you could just simply divide the 9xy by 3y. The y's will cancel. 3 will go into 9 3 times, and you remember x here. So you're going to get 3x by 5x minus 9xy divided by 9x. The 9's will cancel, the x will cancel, and it'll remain with a y. So I'm going to get y by 4y. And that's going to give me 3 by 5 is 15. X by x is going to give me x squared minus y by 4y would give me 4y squared all over 9xy. And that's how we do a question like that. Yeah? Now, if you have something like this, where 5x minus 3y over m. Before I start to work this out, I want you to write this 5x as 5x over 1. Right? Because we're doing fractions. One is a fraction. You need to represent the other as a fraction as well. Right? And just as you would with normal fractions, like imagine you had 5 minus 3/7. You'll put 5 over 1, and then you'll find the LCM of the 1 and the 7. In this case, it's 1 and 7m. So the LCM going to be 7m, because we have to include the variable m. So when we say 7m into this, there's something for the m to go into. So 1 into 7m will actually give us back 7m, right? Because 7m over 1 is 7m. So I get 7m by 5x minus 7m divided by 7m. Now, a lot of students here make a little mistake, and they might put m because that's, for whatever reason, I don't know why they'll put m. But that's not what you'll get, right? If I had 7 divided by 7 and I cancel these, what we'll get is 1. So it's the same thing happening here. When you cancel, we're going to get 1 here, 1 here. The answer is 1. You're dividing 7m by m. So this is actually 1 now multiplied by 3y. So my final answer will be 7 by 5 is 35. M by x is mx. And 1 by 3y will give me 3y all over 7m. Yeah? Everybody right to that? Right, so we're switching it up a little bit. Now we have 8x minus 3y over 5 minus 2m minus 5n. Sorry, I want this to be the same letters. So I'm going to change this to x and a y. Right, minus 2x minus 5y over 3. So again, we're finding the LCM of 5 and 3. That's pretty simple. That's 15. We would say 5 into 15 would give us 3. And then 3 multiplied by this numerator here, 8x minus 3y. I will bring down the minus sign. 3 into 15 is going to give me 5. So now I have negative 5 by 2x minus 5y. Now, this negative sign here is for this 5. So when I'm multiplying or expanding the bracket, I have to multiply this negative 5 by the contents of this bracket. Now, this is where students tend to make mistakes because we have a minus by a minus here. It means that we should get a plus. So let's expand these brackets and see what happens. So 3 by 8x is going to give me 24x. 3 by negative 3y, a positive by a negative is a negative. 3 by 3 is 9, and we're going to get y. Then we're doing a negative by a positive is a negative. 5 by 2 is going to give me 10x. A negative by negative is a positive. 5 by 5 is 25. Y. We're not going to stop there because now we have these two terms here. notice that I'm circling the minus sign with this 10 because it is for that 10. We could work that out, right? We're going to get 24 minus 10 is going to give us 14x because the 24 is bigger. And then we could do negative 9y and positive 25y. Make this circle a little bigger because this positive sign is for the 25. So 25 take away 9, that's going to give me what? 16 plus 16y. Yeah, everybody right to that? And that's going to be all over 15. Easy peasy. Right, so this one is number 7. What about if we had something like 2 over x minus 1 over x plus 2? The LCM here is what tends to confuse students a lot. The LCM is actually the product of the two denominators. So the LCM is actually going to be x into x plus 2. Now, this is why it's important. I was stressing before. When I want to find what the next step, I'm going to say common denominator divided by x, just as we were doing before. And if I do that, then the x's will cancel and I'll remain with x plus 2 as my answer. So I'll get 2, this 2 here, multiplied by x plus 2 minus, if I divide my denominator again, x into x plus 2 by x plus 2, then these will cancel and I'll remain with x. I'll get 1 by x. So my answer on top here now is going to be 2 by x, 2 by 2, that's 2x plus 4 minus x by 1 will give my x all over x over x plus 2. We can now add this and this. Remember, this sign belongs to this x. And what do we get? 2x minus x will give me x plus 4 over x into x plus 2. Now, we can't cancel anything there because this is expression on top and this is expression at the bottom as well. All right? Let's look at one more example. Let's say we have 4 over x plus 2 plus 2 over x. Our denominator, common denominator, is the product of the two denominators, x into x plus 2. And then what we could say is x plus 2 into this. The x plus 2 is going to cancel and I'll remain with x. So I get 4 by x. Bring down my plus. X into x by x plus 2. The x's will cancel and I'll remain with x plus 2 by this 2 on top of here. So I get 4x plus this 2 now multiplied by x here will give me plus 2x. And this 2 multiplied by this 3. This 2, sorry, will give me plus 4 over. So 2x and 4x, we're going to get 6x's plus 4 over x into x plus 2. Yeah? Now we can't cancel anything there, right? Because this is expression and this is expression. Unless we could factorize this in such a way that we could end up, let's just say in our final part, we get something like 4x plus 8 over x into x plus 2. Let's just say, right? What we could do is we could factorize this. So you can see that the 4 is the common factor, and I'll pull out the 4 and I'll get x plus 2. And now this will be over x into x plus 2. In an instance like this, you can cancel, but not here. You can't cancel a piece of this expression with another piece of this expression. Everybody understand that? Does that make sense? Yeah? Easy? All right. All right, look at this Very uncommon type here. What if I have a quarter into 3 minus x plus 1/6 by 1 minus 2x? How would we work this? How would we simplify this? Well, what you will do is you'll actually multiply this entire 3 minus x by a quarter, and that will give us 1 by 3 minus x over the 4, and 1 by 1 minus 2x over the 6. Think about it. Like if I had 1 over 4 multiplied by 24, right? I know we'd cancel something, right? But what you're really doing is you write 1 by 24 over 4 by 1. We usually do these steps in our head. And you get 24 over 4, right? So you want to stick to that same principle. So doing that means that 1 by the brackets here is going to give us 3 minus x over 4. And then we're going to get 1 minus 2x over 6. And then we're back to something very similar where we did before, that we are accustomed to. The LCM of 4 and 6 is going to give me 24. 4 into 24 is going to give me 6 by 3 minus x plus 6 into 24 is going to give me 4 into 1 minus 2x. And that is going to work out to be 18 minus 6x plus 4 minus 8x all over 24. And we could work out our x's, right? If I just grab a different color pen here. Both of the signs are negative, so that means I could keep the sign and add. 6 and 8 is going to give me 14x. And then if I just grab another color pen here, 18 plus 4, that's going to give me 22, right? All over 24. And again, remember, we can't cancel because 2 could go into 24 and 2 could go into 22. We can't cancel like that in algebraic fractions, right? If we cancel, it has to be able to go into the entire thing on top of it, because you have to look at that as a single expression. Okay? Everybody right to that? All right, so look at this one. We have a 5th by 4 minus 3x. So we get 1 by 4 minus 3x over 5 plus 2 in the numerator here by 3 minus x over 10. Right? 1 by this bracket up here, we give them back the exact same thing, these brackets. Plus 2 by 3, we give them 6. 2 by negative x, we give them negative 2x all over 10. Now we find our LCM. So 5 and 10, our LCM is 10. 5 into 10 will give me 2. And 2 by 4 minus 3x. Plus 10 into 10 will give me 1. And 1 by 6 minus 2x. We expand that. 2 4s are 8. 2 by negative 3 will give me negative 6x. 1 by 6 will give me 6. 1 by negative 2x will give me negative 2x. All over 10. We could then add these two together. That's going to give us negative 8x. And we could add this and this together. And that'll give me 14. All over 10. Remember, we can't cancel these here, right? That's going to stay as is. And that's how we work a question like that. Yeah?